Here's something that should bother you. You weigh, let's say, 70 kilograms, 150 pounds. That weight comes from the atoms that make up your body. But if I took all those atoms and removed the space between them, if I packed them together with no gaps, no distance, just particle touching particle, do you know how much space you'd take up? About the size of a grain of salt, maybe smaller. Everything else, all the rest of you, the part that makes you human-sized instead of salt grain-sized, that's the space between your atoms. And most people would tell you that space is empty, nothing there, just distance, just void separating the real stuff. They're wrong, completely, fundamentally wrong. And I can prove it to you, not with speculation, not with philosophy, with physics, with experiments you can do, with forces you can measure. The space between your atoms, the space that makes up most of what you think of as you, is not empty. It's full of something real, something physical, something absolutely essential to your existence. Let me show you what's really there. Stand up right now. Actually do it if you can. Stand on the floor. You're not falling through, are you? The floor holds you up. Seems obvious. Solid floor, solid feet, gravity pulls you down, floor pushes you up. Basic physics. But here's the question. Why doesn't the floor just let you through? Think about it. Your feet are made of atoms. Those atoms are mostly empty space. The floor is made of atoms, also mostly empty space. Empty space should be able to pass through empty space, shouldn't it? Like two clouds passing through each other. No collision, no resistance, and yet you don't fall through. Something is stopping you. Something is holding you up. Something in that empty space is pushing back with enough force to support your entire body weight. What is it? It's not the atoms themselves. The atoms in your feet and the atoms in the floor never actually touch, never make contact. There's always a gap, always a distance between them, impossibly small but real. What's holding you up is a force, an electromagnetic force, and that force exists in the space between the atoms. It reaches across that empty distance. It pushes, it resists. It does work. The electrons in the atoms of your feet carry negative charge. The electrons in the atoms of the floor carry negative charge. And negative charges repel. They push each other away, harder and harder as they get closer. Right now, as you stand there, your weight is pushing you down toward the floor. The atoms in your feet are trying to get closer to the atoms in the floor. And the electromagnetic force is pushing back. The electrons in the floor are screaming, "No, you can't come here. This space is occupied." And that force, that invisible push happening in the microscopic gaps between atoms is what holds you up. So what's in the space between atoms? Force, real physical force, electromagnetic force extending across distance, connecting one atom to another without them ever touching. But that's just the beginning. Now, where does that force come from? How does one atom push on another atom without touching it? How does force travel across empty space? For a long time, this bothered people. It bothered them deeply. You push on something, it moves. Direct contact, cause and effect right there where you can see it. But two magnets repelling across a gap? How? What's carrying the force? The answer is a field. And I need you to understand this clearly because it's crucial. A field is not just a mathematical convenience. It's not just a way of calculating things. The field is real. It exists in space. It has energy. It has momentum. It does things. Every charged particle creates an electric field. That field extends outward in all directions, not just nearby, all the way out, getting weaker with distance, yes, but never stopping, never reaching zero. The field from an electron in your fingertip extends across the room, across the city, across the universe. It's there, everywhere, overlapping with every other electric field from every other charged particle. Now think about what this means for the space between atoms. That space is filled with field, electromagnetic field from every electron, every proton, Every charged particle nearby and far away, layer upon layer of field, overlapping, interacting, creating this invisible fabric that fills all of space. The atoms are not isolated, they're not little balls floating in nothing, they're sources of field, and those fields extend outward and touch each other, connect each other, influence each other across the gaps. So already we have an answer. What's between atoms? Field, real physical active field. But here's where it gets strange. Let me give you a sense of scale here, a sense of just how much of what you call you is actually this space we're talking about. An atom is about 1/10,000,000th of a meter across. That's the distance from one side to the other if you count the electron cloud. But the nucleus, the dense center where almost all the mass is, that's about 100,000 times smaller. 1/10,000,000,000th of a meter. If you scaled up an atom so the nucleus was the size of a marble, a regular marble you could hold, the electrons would be about a kilometer away. That's the scale we're talking about. Now you have roughly 7 times 10 to the 27th atoms in your body. That's a 7 followed by 27 zeros, an enormous number. But if I took all those atoms and removed the space, crushed them together so the nuclei were touching, removed all the gaps, all the distance, all the so-called empty space, you know how big you'd be? About the size of a grain of dust, maybe smaller. Everything else, all the rest of your size, your volume, the physical space you take up, that's the space between atoms. That's what we've been talking about. That's what we're trying to understand. And most people think that space is nothing, just distance, just separation. But it's not. That space, the space that makes up most of your volume, is filled with field, electromagnetic field connecting every atom to every other atom. And that field is not quiet. It fluctuates. It has energy. It's active. You are not mostly empty space, you are mostly field, active, energetic, quantum mechanical field. Let's do a thought experiment. I want you to imagine we could remove everything, every atom, every particle, every bit of matter. We create a perfect vacuum, true emptiness, nothing left. Now, in that empty space, what happens to the fields? You might think they go away, no charges left, no field sources. So the field should vanish. The space should be empty, quiet, still. But quantum mechanics says no. See, fields are not just turned on or off. Fields have energy. And in quantum mechanics, energy comes in discrete lumps, quantum units. You can't have just any amount of energy. You have to have 1 quantum or 2 quanta or 3, but nothing in between. The lowest energy state of a field is not 0. It's 1 quantum, half a quantum of energy in every possible vibration mode. And there are infinite vibration modes. This means the field, even with no particles present, even in perfect vacuum, has energy. It vibrates, it fluctuates, it cannot be perfectly still. This is called zero-point energy. The field at its quietest still has motion, still has activity, and this activity has consequences, real measurable consequences. Those fluctuations can borrow energy from nowhere and create particles. Particle-antiparticle pairs pop into existence spontaneously. An electron and a positron appear from nothing. They exist for an impossibly brief moment, then collide and vanish. Virtual particles, we call them. They exist too briefly to catch and measure directly, but they're real. They affect things. How do we know? There's an experiment. Very simple setup. Very profound result. You take 2 flat metal plates. You put them parallel to each other in a vacuum, very close together. Tiny gap between them, and you measure the force. The plates attract. They pull toward each other. Now there's no charge on the plates, no magnetic field, no obvious reason for attraction. The space between them is vacuum, empty, and yet they pull together with a measurable force, a force that gets stronger as you bring them closer. This is the Casimir effect, and it proves the vacuum has energy. Here's why it works. Those quantum fluctuations, those field vibrations that create virtual particles, they have wavelengths. Some oscillations are big, some are small. When the plates are far apart, all wavelengths fit between them. All the fluctuations happen normally. But when you bring them close, the long wavelengths don't fit anymore. You've restricted which fluctuations can occur in that gap. So there's more quantum activity outside the plates than between them. More field energy pushing in from outside than pushing out from inside. Net force pushes the plates together. You can calculate this force from quantum field theory. You can measure it in the lab. They match perfectly. The vacuum, the empty space between the plates, has measurable energy. It pushes on things. It exerts force. Empty space is not empty. Now, let me tell you why this is so important, why this matters beyond just some plates in a lab. The Casimir effect proves that empty space has structure, has properties, has energy that you can measure, and that affects physical objects. This energy, this quantum activity in the vacuum, it's not just theoretical. It's not just mathematics on paper. It's real enough to move things, real enough to exert force, real enough to be detected by instruments. And if empty space has energy, if it has properties, if it can do work, then it's not empty. The word empty loses all meaning. What we've been calling vacuum, what we've been calling nothing, is actually something, a something with very specific, very strange properties, but something nonetheless. And this changes everything about how we think about space. Space is not a stage where things happen. Space is not a container holding objects. Space itself is an active participant. It has energy. It fluctuates. It creates particles. It pushes on things. The space between atoms in your body is not passive. It's not just sitting there waiting for atoms to do something. That space has energy right now, always. And that energy affects how the atoms behave, how they bond, how they move. Chemistry, the way atoms stick together to form molecules, that depends on the electromagnetic field and the space between atoms. Biology, the way proteins fold, the way DNA works, all of that is mediated by fields in the supposedly empty space between particles. You cannot understand matter without understanding the space between matter, because that space is not nothing. It's field, it's energy, it's activity. So now our answer gets more complete. What's between atoms? Fields. Fields that fluctuate even when nothing is there. Fields that have energy in their lowest state. Fields that create particles from vacuum and make them vanish again. The space between atoms is alive with quantum activity. But there's one more layer, one more thing that will change how you see everything. Let me ask you a question that sounds simple but isn't. What is an electron? You might say it's a particle, a tiny bit of matter with negative charge. That's what the textbooks say. That's the picture in your head. But that picture is wrong. An electron is not a particle, not really. An electron is a disturbance in the electron field, a place where that field is vibrating more intensely than the background. A ripple, an excitation, a wave in the field. The electron field exists everywhere, fills all of space. And what we call an electron particle is just one quantum of energy in that field. One unit of vibration localized to a small region. Same for every other particle. Quarks are ripples in quark fields. Photons are ripples in the electromagnetic field. Every particle is an excitation of some underlying field that extends everywhere. Now think about what this means. You are made of atoms. Atoms are made of electrons and quarks. Electrons and quarks are excitations in fields, fields that extend everywhere, that fill all space, that existed before you and will exist after you. You're not made of stuff, you're made of patterns in fields, ripples that happen to persist, disturbances that got complicated enough to think they're separate from the field that created them. And the space between your atoms, it's the same field, just quieter. The field doesn't stop at the edge of a particle. The particle is just where the field does something interesting. Between particles, the field continues humming at its ground state, fluctuating with zero-point energy, creating and destroying virtual particles. There is no between, really. There's just field. everywhere, in different states of excitation. You are the excited parts. The space is the quiet parts, but it's all field, all connected, all one continuous thing. So here's the final answer. Here's what's actually between the atoms in your body. The same thing the atoms are made of. The same quantum fields, just in a different state. Not empty, not nothing, but the ground state of reality itself. Those fields connect everything. The electromagnetic field in your body extends continuously to the electromagnetic field in the sun, in distant galaxies, everywhere. Same field, not copies, not similar fields. One field extending through all of space. You cannot be separated from the universe because you're made of the same fields the universe is made of. You're a temporary pattern, a local excitation, a ripple passing through. But the field you're rippling in has no edges, no boundaries, no breaks. When you understand this, solid matter disappears. Empty space disappears. What's left is just field. Everywhere, doing different things in different places, sometimes exciting into what we call particles, sometimes quiet in what we call vacuum, but always field, always connected. The space between your atoms is not separating them, it's connecting them. It's made of the same field the atoms themselves are made of, just less excited, less active, but not less real. You asked what's between the atoms, and the answer is everything. The same quantum foundation that makes particles possible, the same field that extends across the universe, the same ground state of reality that refuses to be truly empty. Not nothing, not ever. The universe doesn't do nothing. Between your atoms right now, fields are fluctuating. Virtual particles are appearing and vanishing. Forces are connecting one atom to another across gaps they never cross. The quantum foam is churning with activity too small and too fast to see directly, but real enough to measure, real enough to hold you together. That's what's there. That's what's always been there. And once you see it, the whole world looks different. Solid becomes pattern. Empty becomes full. Separate becomes connected. And you realize you're not a thing in the universe. You're something the universe is doing. A brief, complicated expression of fields that have always been here and always will be. That's the answer. That's what's between your atoms. Everything. Now you might be wondering, if fields are everywhere, if they connect everything, why do we feel separate? Why do objects seem distinct? Why does your hand feel different from the table? The answer is intensity. The answer is pattern. The field is everywhere, yes. But in some places it's excited. In some places it's vibrating intensely. Those are what we call particles. Those are what make up atoms. Those are what make up you. In other places the field is quiet, still fluctuating, still active at the quantum level, but not excited enough to create stable particles. That's what we call empty space. That's what's between atoms. But it's the same field. The difference is just how much it's doing, how intense the activity is, how concentrated the energy is. Think of it like an ocean. The ocean has waves. Some waves are big, storm waves, tsunami waves. Those are like particles, concentrated energy, obvious activity. You can see them. You can point to them. You can say that's a wave. But between the big waves, the ocean doesn't stop. The water is still there, still moving, small ripples, tiny oscillations. Activity that's harder to see but just as real. You're the big waves. The space between your atoms is the small ripples. But it's all ocean, all the way through. And just like ocean waves, you're temporary. You're a pattern that formed, that persists for a while and will eventually dissolve back into the field that created you. The field remains, the pattern changes, but the field is eternal. That's what you're made of. That's what the space between your atoms is made of. That's what everything is made of. Field, quantum field, sometimes excited, sometimes quiet, but always there, always active, always connecting everything to everything else. You asked what's between the atoms, and now you know it's not nothing, it's not empty, it's not void. It's the same thing the atoms are made of. It's the foundation of reality. It's the fabric of the universe itself, and you are a pattern in that fabric, a temporary, complicated, beautiful pattern, but a pattern nonetheless. That's what you are. That's what's between your atoms. That's what everything is. Field, just field, doing different things in different places, but always field, always connected, always one.